Yes, students, good morning. And now, in continuation with the video lecture, today we are going to discuss on the chapter 9, that is mechanical properties of solids. Chapter 9. Mechanical properties of solids. So dear students, what things you have to study on the basis of latest curriculum of CBSE, what topics you have to study in this chapter. The topics are as follows. The first is Hooke's law. You have to study about Hooke's law. Then you have to study about stress strain curve. Stress strain curve. And then Young's modulus. Young's modulus and bulk modulus. These 4 topics you have to study according to the latest curriculum, latest syllabus issued by CBSE. But for understanding Hooke's law, we must have the idea about the stress, strain, all these things you have to know. So first of all, very quickly, I want to revise these things, and after that we will come to Hooke's law. So first of all, as the name of the chapter suggests, that is the mechanical properties of solids. As the name of the chapter suggests about the mechanical properties of solids. And what is the meaning of mechanical? What is the meaning of mechanical? Mechanical means something related to mechanics. Something related to mechanics. And what is the thing which is related to mechanics? That is the force. That is the force which is the only cause for dynamics. Which is the only cause for dynamics of the body. Dynamics of the body. This is the only cause. Force is the only cause. Means if there is a rigid body, if there is a solid body, if a solid body is given to you, and you are applying a force, that is the force which is responsible for dynamics of the body, and if you are going to apply the force over the body, then what the properties of the body is going to be changed? What properties of the body is going to be changed? So obviously, if force is applied on a particular area, suppose this is area, then this force will cause certain deformation in the body. If L, then it becomes delta L. This example I usually used to take while discussing different topics. So certain properties of this body is going to be changed. Then what are the properties? Let us discuss about the properties. So on the basis of the mechanical force or force applied on the body, their bodies can be classified into 2 categories. The bodies, rigid bodies or solid bodies, can be categorized into 2 categories. The first one is elastic body. The first one is elastic body. And what are elastic body? Elastic body, as the name suggests, that elastic body when a force is applied, and deformation is taking place in that body, after the removal of the force, if the body regains its original shape, then that body is called as elastic body. So after removal of deforming force, body regain its original shape, then that body is called as elastic body. Example for elastic body is phosphor branch alloy. Another is quartz crystal, and etc. Other alloys also, there are other alloys also which can be taken in the category of elastic body. So elastic bodies are those bodies which can regain its shape after the removal of the deforming force. That bodies are called as elastic bodies. The another type of body is called as the plastic body. The another type of body is called as this property is called as the elastic property of the body is called as elasticity. That is called as elasticity. Whatever the elastic property developed, or the bodies which are elastic, the mechanical property of the body to regain its shape after the removal of the external force, that property is called as elasticity. Now let us discuss about the plastic bodies and plasticity. Second one is plastic body and plasticity. Plastic body and plasticity. Plastic bodies are those bodies when there is a permanent deformation is observed in the body after the removal of the external force. If there is the permanent deformation in the body, means after the removal of the body, after the removal of the deforming force, the body does not regain its original shape. If the body does not going to regain its original shape, then that type of bodies are called as plastic body, and the property sustained by the body due to its plastic nature is called as plasticity. So the bodies which does not regain its original shape after the removal of deforming force is called plastic bodies, and this property is called plasticity. This property is called plasticity. This property is called plasticity. Now you quite wonder about the fact that which bodies are plastic bodies. So you have ever seen or ever experienced chewing gum, as you are chewing the chewing gum, and when we place the chewing gum between your teeth, the shape of the chewing gum changes, and after taking it out of your mouth, you see that the shape of the chewing gum does not going to be regained after the removal of deforming force. The clay which is used for making various type of pots, in that also when deforming force is removed, it does not regain the original shape. While making chapati, when you use the flour and when water mix and press it, in that case also the flour does not gain its original shape after the removal of deforming force. So these things can be considered as the bodies which are plastic bodies. So these are the examples of plastic bodies and plasticity and elasticity. Now we will discuss about elastic behavior, microscopic concept of elastic behavior of solids. Elastic behavior of solids. Elastic behavior of solids. Elastic behavior of solids. So dear students, look at here. What is the elastic behavior of solids and how elastic behavior of solid comes into picture? Look at here. One of the famous English physicist, Sir Robert Hooke. Sir Robert Hooke. Robert Hooke, who was the great English physicist, and he was performing his experiments on the various rigid bodies by applying forces on that rigid bodies. And what he had observed that when the external force is being removed from the body regain its original shape. And after that he had concluded after seeing these things, after seeing these facts, he had concluded that we can suppose a rigid body is made up of a spring ball model. The model of a rigid body is like a spring ball. So he had proposed a model of elastic body. A model of elastic body. That model is called as the spring ball model. And he has supposed the various atoms situated at different corners and edges of the solid body. And he has supposed that each of the atoms are connected with each other with a spring. Each of the balls, he had supposed that each of the balls are connected with the spring. Now, dear students, tell me one thing. Suppose I had given you a spring and I had loaded the spring with mass m, that is called mg. Mg mass or mg weight is loaded over this spring. Then what will happen? You will see that the spring is going to be elongated. The spring is going to be elongated. And a restoring force, that is a spring force minus kx, F is equal to minus in work energy chapter work energy and power. In chapter work energy and power, that is chapter number 5, we had studied about the work done by a spring force. So F is equal to minus kx is a spring force acting on the spring, which tries to make the spring to bring in its original position. So this force develops a restoring force in the spring, so that after removal of the load, the spring can regain its original shape. Similarly, here also, if forces are applied on this rigid body, if forces are being applied on this rigid body, the rigid body is going to be compressed. And as the rigid body is going to be compressed, because he had suggested that all the atoms are connected with each other by the spring. So if external force is being applied, the spring is going to compress, and by the property of the spring that it can regain its original shape, a restoring force is developed by the spring, and again it comes into its original shape. And from here he concluded that each and every atoms of this solid is connected by the help of spring. So he had suggested a concept on the basis of energy. That each and every body in this universe tries to be in its stable state or in its lowest energy state. So if no external force is being applied, the atoms or molecules of this rigid body are in its lowest energy state. But as we had applied the external force, the internal potential energy of rigid body system is going to be increased. Internal energy is going to be increased, and the body tries to maintain its stable state. So a force, that is restoring force, is developed inside the body in a manner that the body regain its original state and come into its stable state. That is lowest energy state. And so a restoring force is developed in the rigid body. So a restoring force is developed in the rigid body with respect to the deforming force, and the body regains its shape. Yes, students. So we had discussed about the elastic behavior of solids, and in elastic behavior of solids we had discussed that when the deforming force is applied on the body, by the deforming force, a restoring force is developed in the body to maintain itself in stable equilibrium or lowest energy state, and due to that restoring force, the body regained its original shape. So on the basis of this, we had come to different properties of a rigid body or a solid body. So what are the different mechanical properties of the solid body on the basis of that concept? The first one is stress. Stress is what? Look at here. Stress means to say that suppose there is a rigid body or solid body, and on this solid body a force F is being applied. This force is of deforming nature, or you call as deforming force. This force is deforming force. So for this deforming force, there is a deformation in the body, or the body will change its length, since normally this force is acting normally on the body. So there is a normal deformation in the body, and due to this normal deformation of the body develops a force that is called as F restoring. The body develops a force that is F restoring to bring the body in its original shape, or in its lowest energy state or in its stable equilibrium. So stress can be defined as stress on a given body can be defined as the restoring force developed in the body per unit area. Restoring force developed in the body, or you can say that stress is equal to F restoring upon area, or you can say that F upon A. And for an elastic body, as you know that for an elastic body the restoring force F restoring, that F restoring is equal to F deforming. That F restoring is equal to F deforming, and so stress can also be written as F deforming upon area. F deforming, because for an elastic body the restoring force is equal to external deforming force. Now what about the unit of stress? So since it is force upon area, so unit of stress can be written as Newton per meter square, or you can say it as Pascal. But it cannot be confused with the pressure. Force per unit area is pressure also, but stress cannot be confused with the pressure, because pressure is the external force and stress is the restoring force which is developed by the body. So stress is that force which is developed by the body to bring the body in its original shape, and the unit is same, Newton per meter square or Pascal, and its SI unit is dimensional formula. Its dimensional formula, that is equal to m L minus 1 T minus 2. M L minus 1 T minus 2. Stress is not a vector quantity since it is the force upon area, but stress is a scalar quantity. Stress is a scalar. Stress is a scalar quantity because in case of there should not be any direction of the force. Now on the basis of force applied on the rigid body, stress can be classified into different types. So now we will discuss about the types of stress. Types of stress. The types of stress. So first type of stress is normal or longitudinal. The first type of stress is normal stress or longitudinal stress, and as the name suggests, normal or longitudinal stress, it means to say that whatever the force is acting on the rigid body, that is perpendicular to the cross sectional area of the rigid body, that force is perpendicular to the cross sectional area of the rigid body. So for describing normal or longitudinal stress. Suppose we had taken a rigid body, this is the rigid body and this is the cross sectional area of the rigid body, and if the force is applied in this direction normally or longitudinally to the rigid body, then this force is called as this force results in the extension of the wire. This force results in the extension of this wire. So this force can be called as, first of all write it as normal. If deforming force is acting perpendicular to the cross sectional area of the rigid body, then it is called as normal stress. Now normal stress can be classified into two types. First one is tensile stress. Tensile stress means if the force is creating the elongation in the body, if applied force results in elongation of the body. Applied force results in elongation of the body. So tensile stress results in increase in length. Tensile stress, if it is L, then due to tensile stress it will become delta L. So F tensile can be given as tensile stress it is given as F upon A, force per unit area. This is about the tensile stress. Now look at here students, another is compressive stress. And what is the meaning of compressive stress? Suppose there is a rod of length L, and it is supposed to support it on a rigid hinge, and if a force is applied in this direction, then the length of the rod is reduced. It becomes L minus delta L, and this is delta L, the reduced part, and total length is L. So this stress is called as compressive stress. Compressive stress, and it is compression force upon area. This compressive stress can be given as compressive force upon area. Okay, so this is about the compressive force and tensile stress and compressive stress. Now dear students, another thing is, this is about the normal stress. Second is tangential or shearing stress. Tangential or shearing stress. Look at here about tangential or shearing stress. tangential or shearing stress. Suppose we had considered a rigid body and a force like this, not normal force, a force that is tangential to the surface. Suppose this is the rigid body and we had applied a force in this direction. Tangentially we had applied the force. Tangentially, suppose this is, so we had applied the force in this direction, this force on this surface. So if force is applied tangentially, if the force is applied tangentially, then one surface of this solid is fixed, one surface is fixed and the upper surface moves. And the upper surface moves. The upper surface moves, and this is delta L, and this will be the value L, and this angle is theta. This angle is theta. So the shearing stress is given by F tangential upon area. That is, shearing stress is equal to F tangential upon area. Now third one is hydraulic or bulk stress. Hydraulic or bulk stress. Hydraulic or bulk stress. What is the meaning of hydraulic or bulk stress? Look at here. Suppose I have taken a solid sphere. I have taken a solid sphere, and suppose there is a solid sphere and that solid sphere is pressed by applying the force along all the directions. So if the force is being applied in this direction, in this direction, in this direction, in this direction, all the direction the force is being applied. So if the force is applied, then the volume of the solid is going to be changed, but its shape is not going to be changed. Volume is changed. So this stress is called as volumetric stress also. This stress is called as volumetric stress also. So bulk stress can be given as force per unit area. Bulk stress can be given as force per unit area. It is hydraulic stress, it is called as hydraulic stress also, because when we put a solid body in water, then according to Pascal's law, the forces are acting on the body, on the surface of the body along each side, and the body is deformed under the effect of that hydraulic force. So this stress is called as hydraulic stress also.